we meet each other because something is wrong, but there are things which are normal, and that is our capital, and we have to be aware of that capital and hold on to that. So in order to do so, we have to learn about brain development. This is basically how the brain looks like, but it starts forming from inside out. During the first month of pregnancy, the brain is actually a hollow tube. It is called neuronal tube. And all brain cells are born around that tube, which is going to be the future center of the brain. So we call it neuronal proliferation. All brain cells are normally born during the first 3 to 4 months of pregnancy, with rare exceptions. And MECP2 gene really does not play any crucial role in that process, which means all your daughters had a normal number of brain cells born at the right place. The next developmental step is literally called migration. From the site of their birth, brain cells, which we call neurons, they have to travel. They travel to their final addresses, and the brain forms from inside out. This process ends at the 5th month of gestation, before birth, and MECP2 gene does not play any crucial role, which means all girls are born with the normal number of neurons, and they're placed at their normal sites, addresses within the brain, because the MECP2 gene does not play crucial role as far as we know in these first stages of brain development. So this is basically to illustrate the entire process. This is literally the tube, and then this bubble forms, which is going to be the brain, and then it grows more, and then the surface we have these gyruses, which actually increase the number of the surface area. The problem starts during the next developmental step, which is synaptogenesis, which means it is not enough to have intact normal nerve cells. They have to talk to each other. And MECP2 gene plays crucial role in synaptogenesis. What does it mean? Neurons have to talk to each other. We all know that different parts of the brain control different functions. For instance, I'm talking to you now, which means these parts of the brain are the most active. But I'm looking and I see that I have your attention, and that information gets processed through these parts of the brain, which means, yes, continue with the same strategy. If I'm realizing that I'm losing your attention and not conveying my message, I will change the strategy. For that, my neurons have to talk to each other very fast. And that is where the MECP2 gene affects us. Basically, this is the core, this is the body of the nerve cell. And if it is damaged, we cannot repair it. But it is not damaged in our cases. Basically, what is damaged is branching. If this is a normal brain cell, this is how the brain cell in the Rett patient looks like. Branching is missing. And because the body is intact, we are hopeful that we can help neurons branch out. So please keep in mind that we have strengths. We have strengths which are important from the educational, but we have biological strengths. That is, we have our capitals, and that makes us different from other patients with genetic disorders, because the branching is impaired. And we know that the disease starts around approximately about 1 year of age. There is a range. This is where the head stops growing. This is the head circumference growth chart. This blue area is the area of the normal growth. So everywhere in between this line and this line is normal. And you see that we start normal, and then the MECP2 gene really becomes important for the development of the brain, and the chart goes up, but we do not, our head does not become smaller, it just the chart goes up, but it plateaus. And that is because of this branching. we are looking now at the density of cells. So this is a newborn baby, this is 6 months, and this is 2 years, and actually we do have problem between these two periods. And this is not the number of cells, it is the branching of cells. They don't talk to each other. Talking to each other, there is a saying, neurons which fire together, wire together. That is, now we are coming back to the talk about motivation, because the more we force girls to think, to do things and to use their brain cells are going to fire together, and they are going to wire. So the more this is one synapse. This is connection diagram of connection in between the two neurons. So they talk to each other, which means this one sends a signal to this one, and then it sends to the whole neuronal network. The more time this presynaptic neuron causes postsynaptic neuron to fire, the easier firing is going to be. It is like when we dial the phone number. If we dial it once in 5 years, it will take 5 days to look in our books to find it. But if we dial the number 5 times a day, we will just know it right away, because we are not aware that we know. That means the neurons which fire together, they wire together. Therefore, activation and motivation is crucial. This is just the illustration of what I told you. The different parts of the brain have different biological roles, and we need all of them. So why are we different? They're different. These are pictures from the web, and this is one of our friends, who is now in Disney World. So basically, why are we different? We are different because of this period. Basically, course of the Rett syndrome has a changing pace. We start at the birth, we look well, and we start developing about 12 months. Other patients with Down syndrome, with different genetic diseases, they do not have that luxury. They don't have that a normal period of development. And that normal first stage is because their gene is necessary for earlier stages of brain development. So this is our capital on which we bet, because there is a normal foundation. Then there is a really tough period, and each of you know that better than I do, because I never experienced it at my own home. But the second period is this long line where we are stable. So it is not a degenerative disease that we go downhill. To conclude, the gene mediates final stages of brain development, does not play an essential role in the early stages of brain development. Historically, we are talking that the disease was first described in 1966. It took 33 years to understand the reason, what causes the disease. We did not know. Is it abnormality in the brain structure? Is it metabolic? We were running tests. We didn't know. I was a neurologist at that time. I was diagnosing girls in the waiting room, but I didn't know what caused their impairment. So it took 33 years. Only after 8 years, it took 8 years to cure the animal. So the science is speeding up. In the spirit of our optimism and our capital, which we have to be aware of, we are dealing with problems, but we have to be aware of our capital. Please come celebrate the party with us, opening of the Jamie's Library on December 27th. Thank you very much for coming.